Okay, we're going to start off here with our discussion. You should have watched the video over single replacement reactions yesterday or last night. Now, you might want to take out your help sheet too that I gave you yesterday. So I'm going to pull up the help sheet just to give us a quick overview of the main players in the single replacement right here. We have a metal plus an aqueous salt. Remember, all an aqueous salt is something that is ionically bonded. Okay, aqueous means it's dissolved in water. So a metal with an aqueous salt will yield a new metal and a new salt. An active metal plus water. Now we're going to have to check on our activity series for that particular one, but we'll do that when we work the examples. That's why we have our activity series out. Okay. Metal plus an acid will give a salt and hydrogen gas. A halogen with an aqueous salt will give a new salt and a new halogen. It's important to note because all of these single replacements we're dealing with metals. Okay? All of these we're dealing with metals or hydrogen except for number 4. Number 4 is dealing with halogens. So it's important to make a mental note of halogens that are being involved with this. Finally, the last one is a metal oxide plus hydrogen will give a metal and water. So those are the 5 different types of a single replacement reaction. So the very first one that we are going to work here, sodium oxide plus calcium. Now let's scan down through our 5 single replacement reactions. Which is this? 1, 2, 3, 4, or 5? Okay. 1, 2, 3, 4, or 5. What do you think? Could it be 1? A metal and an aqueous salt. Well, that is an aqueous salt, and that is a metal. Okay? Could it be number 2? An active metal and water? No. Could it be a metal and an acid? No. Could it be the replacement of a halogen? I see oxygen. That's a halogen. Well, that's not even a halogen. No, it can't be. I was thinking Super 7. We don't even have a halogen up there. Is it a metal oxide and hydrogen? No, so it's got to be what? Number 1. Okay? So this is number 1. So I am going to get a new metal and a new salt. Now, what I need to check, okay, on my activity series. Okay, so I'm going to write this out. I know sodium oxide plus calcium. I need to look to see if calcium is strong enough, if calcium is active enough to replace sodium. So, I click over to my activity series. I need to find calcium. I need to find sodium. Correct? There that thing is. I couldn't find my thing here. Now, as I'm looking, here is sodium. Is calcium active enough to replace it? Yes, it must be above it on the chart. So calcium is active enough to replace it. So I am, well, that's not working real good. I am going to replace that. So, when I did this particular one, I'm going to get a new metal. And a new salt, right? What is my new metal going to be? Well, it's going to be what is replaced. What's being replaced? Sodium, right? What is my new salt going to be? CaO, calcium oxide. Remember, I like to say the word calcium oxide and then write the formula. Calcium is a 2 plus, oxygen's a 2 minus, so it's going to be CaO. It would not. Is sodium a super 7? No, so it would not. Okay? What Rachel's asking is, should I put a 2 here? Okay? Sodium is not a super 7, is it? The only ones we have to put a 2 like that is super 7s. So that 2 does not belong there. We're going to take care of that when we balance it. Okay? That'll be taken care of in the balancing. So I've got my new metal. I've got my new salt. Now all I have to do is go through and balance my chemical equation. And all I need to do, I believe, is just put a 2 right there, isn't it? To balance. Okay. Moving on, moving on. Here's my next one. Iron plus copper 1 chloride. I go through my checks. Metal and an aqueous salt. Could be. Active metal and water, no. Metal and acid, no. A halogen, no. Metal oxide and hydrogen, no. So this is single replacement number 1 also. I write iron plus copper 1 chloride. Copper is a 1 plus. Chloride is a 1 minus. So it's going to yield, once again, we're going to get a new metal and a new salt. Where do I go from here? I have to check my activity series. Okay? Will iron replace copper? Iron, copper. Iron, copper. Here's copper. Okay? Iron's way up here. So will iron replace copper? Absolutely. So I come back here. My new metal is going to be copper. What's my new salt going to be? What's my new salt's name? Iron chloride. And, well, Brooke brought up a good point. She said what? Iron 2 chloride. Could we have picked iron 3 chloride? Do we know which one it is? We would have to test that. We would have to do a test. So, if on any paper you would put iron 2 and you would put iron 3, that would be fine. My answer key would have both of those. Okay, because we don't know until we do some testing. Which one's better? Neither. 6 one, half dozen the other. All right. So, Brooke said iron 2, so we're going to put iron 2. Fe is a 2 plus, chlorine's a 1 minus, iron 2 chloride. Am I finished? No, because I have not balanced this guy. I need to balance this guy, and as I balance, I need 2 chlorines. That means I'm going to need 2 coppers. I believe that now I'm okay. Agree with me? Is this balanced now? Now, can you see, folks, how many of the things, how many of the skills you are using right now that we've done throughout the year? Okay? You're using a bunch of different skills that we've done throughout the year just to do these reaction predictions. Okay? Now, let's say that I used iron 3. And I'm going to show you how it would be different. How would it be different? I would balance it different, wouldn't I? I would need to have a 3 here and then a 3 here. So it would be similar, but not. Here is number 3 example. Chromium plus steam. Now, what is steam? H2O in the gaseous form. Okay? That makes a difference. That makes a difference. Chromium plus water. And I know it's steam, so I'm just going to write that gas in parentheses. Now, which number am I looking at? Okay. I am looking at the one with water, correct? Which is number 2. Okay, number 2. So my products are going to be a metal hydroxide plus hydrogen. Now where do I go? To the activity series. Now, on this part, okay, you can see that I have a couple of lines that are going to be important to me. Right here is one. Reacts with cold water to liberate hydrogen gas. So anything above that line will react with cold water. I have another line right here that says reacts with steam, liberating hydrogen gas. Okay? So, it makes a difference what type of water I'm dealing with, whether it's liquid, whether it's steam, because these right here will not react with cold water, but they will with steam. Okay? So, I look at this. Does chromium fall into that area? It will react with steam, won't it? So this reaction will occur. So what is my metal hydroxide? The name of it. Chromium hydroxide, right? Now, can chromium take multiple? Can chromium take multiple? Yes, it can. What could chromium take? Because it's got a periodic table out. 2 and a 3. Okay. Let's just say we're dealing with chromium 2. So, I'm going to put chromium 2 hydroxide, and hydrogen. Remember, hydrogen is a super 7. Hydrogen is a super 7, so it's got to be diatomic. Now, I need to balance. All right? And looking at this, everything should be, if I put a 2 here, my hydrogens are okay, my oxygens are okay, and my chromiums. So I believe that if I put a 2 right there, I am good. What do you think? Because I've lost my example paper somewhere. Is that right? Balanced? Good to roll? How can I just walk in this little area right here and lose a paper? It's kind of crazy. So, right here, I have the single replacement reaction dealing with water. The next one. Oh, wait, I didn't lose it. Here it is.
Okay, so I'm looking at the worksheet we have to do tonight, and one of them says
I'm not there yet.
hot water.
Count it as steam. Yeah. If it says hot water there, we'll count that one as steam. All right? All right. Yeah, Brittany? Okay, I'll get you one. Zinc. Let's keep going with the examples. Zinc plus hydrobromic acid. Obviously, we have an acid right there, so that should go ding, 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 ding. I am dealing with the single replacement that has the acid in it. Which one is it? Number 3. So this is single replacement number 3. Zinc plus hydrobromic acid yields. So now we're bringing in naming acids once again. Naming acids. Now, I have a line right here that is dealing with reacts with acids liberating hydrogen gas. Okay? So I need to check reacts with acids liberating hydrogen gas. What was zinc? Is zinc above that line? Yeah. So this will occur. This will occur. So I am going to have, I guess I didn't write out what I'm going to make. I'm going to make a salt and hydrogen gas. So my salt is going to be what? What's the name of my salt? Zinc bromide, because my zinc's going to replace the hydrogen. Zinc is a 2 plus, bromine is a 1 minus. Zinc bromide. Look at that crud. Zinc bromide and hydrogen. Remember, hydrogen's a super 7 again, so it's diatomic. I'm not done yet, though, am I? How am I going to balance? Put a 2 right there. Now I have a balanced chemical equation. How many more examples I got? Oh, here we go. Now, what should jump out at you here? What should jump out at you here? I'm dealing with super 7s here. I've got halogens, right? So what is going to happen here is the halogen is going to try to replace the other halogen. Are halogens on our activity series? Yes, but no. Okay? Yes, but no. I have a lot of folks do this. I have a lot of folks do this and say, okay, I'm trying to find bromine on here, Mr. Braun, and I can't find it. Okay? That should ring the bell off too if you didn't recognize. That should ring the bell off too. If it's not in this row right here, if it's not in that middle row, it's gonna be over here with my halogens. And that should jar your memory into, oh, this is number 4. I'm replacing a halogen. Okay? So, what I have here, bromine. I know bromine's a super 7. Sodium iodide, NaI. So, I am trying to replace what with what? Iodide with bromine. Okay, a lot of people want to try to replace bromine with sodium. No, a halogen replacing another halogen. So I'm trying to replace iodine with bromine. I look on my series. Is bromine capable of replacing iodine? Yes, it is higher up. So will this reaction occur? Yes. So what I am going to get is a salt, a new salt, and a different halogen. So my new salt is going to be sodium bromide. My new halogen is going to be iodide. Now all I need to do is balance the equation. And to do so, here, should balance it up. Okay? Now, ladies and gentlemen, what do you think? Those are all the examples that I have. Can you give me a thumbs up? Are we ready to try our worksheet? We ready to roll with the single replacement worksheet? Let me check. First row's good. Second row. Third row. Okay, your homework is the single replacement worksheet and also a pre-lab video. We are doing a lab tomorrow, so a pre-lab video.